So in this video, we're going to go over how to do heat transfer problems. We're going to start with this equation, and whenever we see equation, I really suggest in your notebook to flip to the back page or to have a spare piece of paper that you'll always put in your equations. That way, whenever you have to do a calculation, you have one resource to go to in your notebook, again, either at the back or a separate piece of paper where you're going to keep all of those equations separate. So in this equation, we can see that we're going to be looking at the heat lost versus the heat gained, or in this case, Q just stands for energy in the form of heat. In breaking that down a little bit further, we can see that we have M on both sides, which is going to stand for our mass. And then we see this triangle and this T together. Whenever we see that triangle, the triangle just stands for change in, and it's whatever variable comes next, the T being temperature. So putting these two together, triangle T just stands for change in temperature. Another way, or what we actually call the triangle, is delta. So delta T, or change in temperature. And then our final variable is that CP, or specific heat. Take a look at how to solve one of these problems. In this problem, I'm going to start by going through and reading it, and as I read, I am going to highlight. Because we have two different situations here, we're going to have one where the heat is lost and one where the heat is gained. I'm going to highlight the information in different colors as I go. So one for lost and one for gained, and then if there's anything that goes to both of them, I'm going to highlight that in even a different color. So reading through, a piece of unknown metal with a mass of 32.9 grams is heated to an initial temperature of 80 degrees Celsius and dropped into 4.5 grams of water. So we can see that we have a different compound here. Again, I'm going to go ahead and switch up my color. So 4.5 grams of water. The water has an initial temperature of 15 degrees Celsius, and we're putting the metal into water that is in a calorimeter. Remember that the calorimeter is just the machine that I use in order to figure out heat transfer or measure heat transfer. The final temperature of the system is 62.4 degrees Celsius. So whenever I see the word system, that means everything combined here. And since we're taking that metal and we're putting it in the water that is inside of the calorimeter, all of that together, the metal and the water, are going to have a final temperature of 62.4. So again, that 62.4 degrees Celsius as the final temperature is going to apply to both of those things. The specific heat of water, going back to water, is 4.184 joules divided by grams times Celsius. The question that this is asking is, what is that specific heat of the metal? So that is going to be our variable here. So the specific heat of the variable, when it comes to it, I'm going to put it as the variable X. The specific heat of metal will be variable X. So let's take a look at what I have, and to do that, I'm actually going to fill out a table to help me stay organized. I'm going to use the same color as I'm writing in and taking my information from my word problem. I'm going to start with my metal, and I'm going to go down and do all that first. So I'm going to pay attention to those yellow highlights. So my metal mass is 32.9 grams. The initial temperature is 80 degrees Celsius. The final temperature, remember, that was the thing that they shared in common. So it's orange, and I can actually fill that out for both water and for metal, which is that 62.4 degrees Celsius. And again, same for both because they're both within the system here. Finally, my specific heat of the metal is the thing that I don't know, so I'm going to put my variable there. We're going to come back to the delta T, or the change in temperature. For right now, we're going to switch over to the red highlights, which are my water. So the mass of my water is 4.5 grams. The initial temperature of the water is 15 degrees Celsius. And that specific heat is 4.184 joules, which is my J, divided by grams times Celsius. Now this is not super important right now, but it can be helpful to get into the process of checking your units. As you move further in science classes, you're going to be sure to always check your units. So we can see that our units for mass are the same, grams. Our units for temperature are always the same, Celsius. And when we look at our more complex or energy, we have joules, which is the actual energy value. And then we have grams, which still goes back to our mass. And then we have Celsius, again, going back to our temperature. So having the same units across all of our variables is extremely helpful. Again, as you get further on into science classes, you'll learn more about transferring those and converting them when they are not. But for right now, we're going to go ahead and move along with the problem. Before we do that, I'm going to clean our bit so it looks a little bit nicer. And now we're going to talk about that delta T. So delta T, you'll see we always solve this by taking our final temperature, which looks like T of F, minus our initial temperature, which is T of I. So final minus initial temperature, which again, we have set up on our data table here. So for each one of these, we're just going to be taking our final and subtracting our initial temperature here. So we have 62.4 minus 80. So keep in mind, because the 80 is bigger, we're going to have a negative value here. So we have negative 17.6. Again, that's degrees Celsius. And then again, we're looking at the same thing. We're going to take our final minus our initial over here for our temperature of our water. So in this case, we have 62.4 minus 15 for a change in temperature of 47.4. Again, making sure that we keep those negatives. So if we're ever subtracting a number that is higher, we're going to have a negative number. So make sure to keep those negatives in mind as we go through. So in clearing up our data table, something that we might notice from our equation that is up here is that we don't really need our T of I or T of F anymore. So I'm going to clear those up by taking them out of the picture, and I'm actually going to get rid of this problem too, just so that we can go through with a clear slate. So again, because we already have our initial and final temperature where we need them within our change of temperature, I'm going to go ahead and clear them out as we go through and solve this next problem. There we go, much cleaner. So as we go through, we're just going to substitute in the values that we have. So mass for the metal is going to be 32.9 grams. Temperature is going to be that negative 17.6, and our specific heat is going to be X. Remembering that we have to keep that negative out front here. That's going to be super important as we go through our problem. So keeping that negative number because it's in our equation. Going through the second part, so for our water gain, we have a mass of 4.5. For our temperature change, we have 47.4. And for that specific heat, we have 4.184. So setting these things equal. Now what we're going to do is we're going to, one at a time, go through and solve. So we have 32.9 times negative 17.6, and we're going to take the opposite of that. So because we have a negative times a negative, we're going to wind up with a positive, and our variable of x stays out. Moving over to the right-hand side, we have 4.5 times 47.4 times 4.184, giving us our total on the right-hand side, or our product. Now, we look like we've cleaned everything up, but we still have to solve for that x, so we're going to use our inverse operations here. Currently, we're multiplying by x, so we're going to have to do the opposite, which is divide. And whatever we do on one side of the equation, we got to do the same on the opposite. So we're going to divide by the 579.04. We're going to be left with x on the left-hand side and a specific heat of 1.54 joules divided by grams times Celsius. So if you're ever confused on what those final units are, keep in mind we're solving for that specific heat, that CP here, and our initial specific heat was joules divided by grams times Celsius. So that can help you figure out what those final units are. All of your calculations should be two-parted. You should have the number and the unit there. So congratulations on sticking with me and solving this problem. Did a great job. Make sure to always show your work whenever there is a short answer question in order to get full points. If you have any questions, find me in the virtual office and we'll go over it together.